Okay, last time we simplified some expressions, some trigonometric expressions. Today we're going to actually verify some identities. So we're going to prove some identities. So let's just throw one up here and let's see how this works. Someone is claiming that this is an identity. So remember what that means is someone is claiming that no matter what you let x be, 17 degrees, 1.4 radians, whatever you let x be, this will be a true statement. Your job is to prove that. Now, as with all things mathematics, there is never just one way to do it. I've done a lot of these. I really actually enjoy doing them. And some things I've picked up through my practice that I think make the problems easier. But take them or leave them. There's no hard and fast rule. What we're going to try to do is change one side into the other side. So we're going to manipulate. In this case, I'm going to start over here, and I'm going to try to make this simplify into this. Now, the reason I'm picking this side is because there's a very clear and obvious way to begin. Tangent is sine over cosine. Secant is 1 over cosine. So a very clear way to begin. If I started over here, are there things I can do? Absolutely, but they're not quite as obvious. So I'm going to do this. Now, the happy news is we have a common denominator already. We have two fractions, and we can add them together. Now, the bad news is it doesn't match that, and I need to see if I can make that match that. So, one thing you can think about is, okay, if I want that to look like that, what if I multiply top and bottom here by cosine? Now, that's perfectly legitimate. You can multiply the top and the bottom of a fraction by the same thing. You've done it a million times. Maybe not with cosines, but you've done it a million times. Multiply top and bottom by 2. So we're multiplying top and bottom by cosine. Now, why did I do that? Why did that even occur to me? Well, this is my end goal. This is what I want to end up with. And I notice there's a cosine up there. So I don't have a cosine up there, so I'm going to stick one up there. Now, there are other ways I could go, but this is a strategy for you to file away and keep as you pursue your own problems. All right, so now what have I got? I've got this cosine times sine plus 1 over cosine squared. Now, please don't cancel because that'll take you right back to where you started. Instead, I want you to look at this cosine squared and I want you to look at this denominator. Remember, sine squared, I'm doing this over to the side, sine squared plus cosine squared is 1. So cosine squared is the same as 1 minus sine squared. Your identities that we talked about last time can appear in or be used in various forms. So cosine squared is the same as 1 minus sine squared. So I'm going to take this problem right here and I'm going to rewrite the denominator. I'm going to rewrite the denominator as 1 minus sine squared. Now remember, this is my goal. I've taken my cosine squared and rewritten it as 1 minus sine squared. I'm still trying to equal this over here. Now, 1 minus sine squared is the difference of squares. Remember, a squared minus b squared factors as a plus b, a minus b. This is the difference of squares. So that's going to factor, I'm just recopying my numerator, but that's going to factor as 1 minus sine, 1 plus sine. Wait a minute. These will cancel. And look what I am left with. I am left with cosine x over 1 minus sine x, which is exactly what I wanted. So all the way down, I've been kind of carrying this, hoping that that's what I end up with. And sure enough, I did. So in the course of doing that problem, we used an identity, we factored as the difference of squares, and we got a little creative over here in the beginning by noticing that, I need a cosine on top, so let me just put one up there, and everything worked out. So the actual proof, that's all extra stuff up there. The actual proof is one big long string, this on the bottom here. So eventually you've shown how you've changed this through all these steps into the right side. All right, let's try another one. Sometimes these are shorter and sometimes they're longer. And that, of course, depends on what strategy you're using. I'm sure you remember from geometry, when you were doing your deductive proofs, you know, your statements and reasons and all that, that somebody would do it in 5 steps, and it would take somebody else 15 steps. That doesn't matter. As long as you get to the end goal, obviously, if you can do it more efficiently, that's great, but as long as you get to the end goal. All right, here's another one. And I hope I copied that right. All right, so somebody has decided this is an identity, and you are going to prove it. So I think it's pretty clear I'm going to start work over here because I've got a tangent and a cotangent, and I can change those into sines and cosines, which would be a good thing because that's all I have on this side. So I'll leave my cosine out here, and then this is going to be sine over cosine. This is sine over 1 times cosine over sine. I'm multiplying those two together. Well, so I've got my cosine, got my sine over cosine here, but this part of the problem, this guy right here, he's going to cancel into just cosine. So now I'll do my distributive property. So I'll take cosine times this, so that'll give me just sine. And I'll take cosine times that, and oh my golly, there it is. Sine plus cosine squared. Now that one was a lot easier. Didn't have to do anything tricky on that one. We just changed our tangent and our cotangent into sines and cosines. Remember those the quotient identities. And then we did the distributive property, and it just magically worked out. Whew, that's exciting. Let's try another one. We'll just try a couple more. Work through them, and then you can have some fun with these on your own. So here we go. We got the tangent plus the cotangent equal to the secant times the cosecant. Now, it's a little bit tougher. I mean, neither side is really obvious about where to start because I could change these into sines and cosines, and I could change these into sines and cosines. My experience, and other people may feel differently, but my experience has led me to work on the side that has an addition or a subtraction. So if there is no clear place to start, obvious place to start, I'm going to work on the side that has a plus sign. And I think you'll see why here in a minute. Why this might be the easiest strategy. In order to prove, you've got to keep moving. You don't want to get to a point and be stuck. If you get stuck, then you either have to start over again, or you have to get really creative. If I start over here on this side, the first step is completely obvious. Tangent, sine over cosine, cotangent, cosine over sine. Obvious. The second step now is equally obvious. I am adding two fractions. So in order to add two fractions, I need a common denominator. So my common denominator will be cosine sine. That's going to be my common denominator. This one, I'll have to multiply top and bottom by sine to get the common denominator. And this one, I'll have to multiply the top and the bottom by cosine to get the common denominator. Common denominators in trigonometry work just like they do in arithmetic. You just want to make them match. So if I have to have one of each, then this one needs a sine and this one needs a cosine. So now I have my common denominator. So I'm going to write one fraction. When the denominators match, you can write one fraction. So this numerator is sine squared, and this numerator is cosine squared. Oh my gosh, your blood should just be pounding at this point, or your heart, I should say, should just be pounding, because sine squared plus cosine squared is 1. So we have 1 over cosine sine. So I'm going to start over here because I want you to see how this works. We have 1 over cosine sine, and we want to end up with this. So remember, when you have a multiplication, you can actually separate that. You can't do that with an addition or a subtraction. But when you multiply fractions, you go straight across. So 1 times 1 would be 1, and cosine times sine would be cosine sine. See how you can split that apart? Can't split it if it's a plus, but you can split it if it's a times because of the way we multiply fractions. Well, 1 over cosine is secant, and 1 over sine is cosecant. So we ended up with exactly what we were hoping to end up with. So again, your goal is to pick a side, and it never matters which side, it's just which side you're going to be able to do something with. So I picked this side, I worked down, and lo and behold, I ended up with exactly what I wanted. Beautiful. Okay, let's look at maybe 2 more. And then you can start practicing. Because these just take practice. You'll get really good at them. Maybe you're already good at them. We just need to make sure we are practicing. So 1 over secant minus 1 plus 1 over secant plus 1 equals 2 cotangent cosecant. Oh my goodness. I think I'm going to start over here. And I think I'll go ahead and start by just getting a common denominator. So if I get a common denominator, because I'm adding the fractions, my common denominator will be secant minus 1, secant plus 1. That will be my common denominator. Oops. And I'm going to need to multiply this one by secant plus 1, and this one by secant minus 1. So now my numerator, now the denominators match, see, they match. So now my numerator over here, that's a distribute, but it's a 1, so it doesn't really matter, secant plus 1 plus secant minus 1. Well, I'm a little bit overjoyed here because the ones are going to cancel, but I see where I'm going to get my 2 now because I have 2 secant. That's what's left on top, secant plus secant, 2 secant. Over, and I think I'm going to go ahead and FOIL that out. So that's going to be secant squared. I'm foiling now, regular FOIL, first, outside, inside, last. So I've got my 2 secant on the top, and then on the bottom, these are going to cancel, and I have secant squared minus 1. Now, over to the side, I want you to think about your Pythagorean identities. There is a Pythagorean identity that involves a secant and a 1. Do you remember that? The identity says 1 plus tangent squared is secant squared. So tangent squared must equal secant squared minus 1. In other words, if you have secant squared minus 1, you can replace it with tangent squared because of that identity. So now I have 2 secant over tangent squared. And I need that to equal 2 cotangent cosecant. I'm still trying to get it to equal that. Now I'm here. Okay? Now, I'm going to keep my eyes focused on what I want to end up with, and I'm going to rewrite this for a second. Okay? I'm going to rewrite this as 2 times secant times 1 over tan squared. That's what I've got here, right? I've got 2 times secant times 1 over tan squared. Now, what is prompting me to do that? Well, I've got a cotangent, and I know cotangent is reciprocal of tangent. Now, it's not a cotangent squared, but at least recognizing that I've got that situation. So I have 2 secant times cotangent squared. That's what this equals. 2 times secant times 1 over tan squared. That's 2 secant cotangent squared. All right, now I'm going to rewrite my secant as 1 over cosine. And I'm going to write one of my cotangents as cosine over sine. And I'm going to leave the other cotangent because I want to have a cotangent in my answer. So when I got this separated, I wrote secant as 1 over cosine, and then I have 2 cotangents. So I left one of them alone and changed the other one into cosine over sine. All right, so what's going to happen? Well, what's going to happen is these cosines are going to cancel. That's all multiplication, kids. So I have 2 times 1 over sine times cotangent. That's what I have left. 1 over sine is cosecant. So lo and behold, I ended up with exactly what I wanted. Wow, pretty cool. Let's do one more. Notice we're using our identities, our known identities, in different orders. You're mixing them around, but they're really, really important. Okay. Do not be frightened. Do not be afraid. You can do this. You can do this. I promise. You might, I don't know what occurs to you when you look at this problem, but I see a whole bunch of cosines over here that aren't over here. So you've got a couple of different options that you can do, and I think I'll show you both options. But right now, let's suppose we started over here with this great big giant power. Because very often in math, we want to break things down. So let's break down that cosine to the fifth. So let's think about that as cosine times cosine to the fourth. Now, one of the reasons I did that is I have to end up with one cosine. So I got to kind of keep him because I need to end up with him. But I don't need these. So I'm going to remember that sine squared plus cosine squared is 1. So cosine squared is the same as 1 minus sine squared. Well, cosine to the fourth, guys, is cosine squared squared, right? Cosine squared squared is cosine to the fourth. So I'm going to replace that cosine squared right there with 1 minus sine squared. So I have 1 minus sine squared squared. Which, when I FOIL it out, 1 minus sine squared times 1 minus sine squared. A lot of writing. 1 minus 2 sine squared plus sine to the fourth. One, FOIL it out. Now I bet you can see what you're going to do now. If you take this sine squared and distribute it, you're going to have sine squared minus 2 sine to the fourth plus sine to the sixth. If you take the sine squared that's out here in front and distribute it times this, remember multiplication is commutative. So you can multiply this times this, and then we still have that cosine, and there it is. That's what you wanted. So we accomplished at that time, I'm going to do it differently here in just a second, but we accomplished at that time by breaking apart the cosine to the fifth. Now you could have also, and when you broke apart the cosine to the fifth, you had to pay attention to the fact that you got an identity that says cosine squared is 1 minus sine squared, and this is cosine squared squared. So then you could do your direct substitution. What if you decided, when you looked at the problem, that I've got way too many signs on this side. I'd like to get rid of some of those signs and rewrite them as cosines so that I would have 5 cosines instead of just 1. So in other words, what if you decided to change this side into this side? Perfectly legitimate. If you want to change this side into this side. Okay? So first thing you might notice about this parentheses is you can factor out a sine squared, which is a good thing because you have one over here. Remember, this time in doing the problem, I'm going to change the right into the left. So this is now my goal. So factoring out that sine squared helps me. So sine squared now I have 1 minus 2 sine squared plus sine to the fourth. Now, if you're really in tune, you're going to notice that this factors. That is exactly the same as 1 minus 2n squared plus n to the fourth. That factors as 1 minus n squared times 1 minus n squared. Now look at that. This is exactly the same as this. And you would factor that. So this would factor as 1 minus sine squared times 1 minus sine squared. This trinomial right here factors. If you don't believe me, FOIL it back and you'll get this. And then we know that 1 minus sine squared is cosine squared. So we have a cosine squared here, and a cosine squared here, and a cosine on the end that was part of the original problem. And there it is. You've got your sine squared times cosine to the 5th, which is exactly what you wanted to end up with. Cosine squared, cosine squared, cosine. Okay, well, it's time for you to do a little practice now on your own. Good luck, have fun. I think you're going to enjoy these.